Namaskar and a warm welcome to the series of lecture. Myself, Dr. Praveen Kumar Sahu, belonging to Government Sama Prasad Mukherjee College, Sitapur, Chhattisgarh, India. And this is a lecture pertaining to MSc Mathematics 4th semester of Sant Gahira Guru University, Sarguja, Chhattisgarh. And the paper is 5th paper, Numerical Analysis 2, and the unit is 4th unit, Solution of Algebraic and Transcendental Equation. And this is my first lecture on this unit, so this is just an introductory lecture. So let's start the lecture. First of all, we will see the points that we will discuss in this lecture, means outline of the lecture. In this lecture, we will define algebraic and transcendental equation. Then we will define the root of an equation. Then we will see the method of finding the roots. Then we will discuss the intermediate value theorem. And we will discuss some example based on this topic. So let's start. However, we have already defined algebraic and transcendental equation in previous classes. But for the sake of completeness, let's revise what are algebraic and transcendental equation and why we need them. As we know, suppose we have an equation of the form fx is equal to 0, then we can divide it into two parts. First is algebraic equation and second is transcendental equation. Now, what is algebraic equation? If the equation fx is equal to 0 is a polynomial, then it is called an algebraic equation. Means a polynomial equation of the form a naught x to the power n plus a1 x to the power n minus 1 and so on plus an minus 1x plus an is equal to 0. Here a naught should not be 0 is called an algebraic equation. In general, here the powers of the coefficients are positive integer. Let's see some example of algebraic equation. Suppose we have an equation of the form x to the power 4 minus 4x square plus 5 is equal to 0, or 4x square minus 5x plus 7 is equal to 0, or x to the power 6 minus x to the power 4 minus x to the power 3 minus 1 is equal to 0. So these are the examples of algebraic equation. Now, transcendental equation are also known as non-algebraic equation. So in general, an equation which is not algebraic is known as transcendental equation. But more specifically, we can define an equation which contains polynomial, trigonometric function, logarithmic function, exponential function, inverse trigonometric function, hyperbolic function, etc. is known as transcendental equation or non-algebraic equation. Let's see some example of transcendental equation. 10x minus e to the power x is equal to 0, x e to the power x minus 2 is equal to 0, x log x minus 1.2 is equal to 0, 7x to the power 3 plus log of 3x minus 6 plus 3 into the power x into cos x plus 10x is equal to 0. These are some example of transcendental equation. Now, we know what is root or 0, but again, let's revise what is root of a 0 equation. We know that for an equation f x is equal to 0, the root or 0 of an equation is that value of x, for example, x is equal to alpha, for which f of alpha is equal to 0. Means it satisfies the given equation fx is equal to 0. So, finding the root of fx means solving the equation fx is equal to 0. Here the root may be real or it may be complex number. Finding the root of an equation is a very important problem in science as well as in engineering. Now, we will see the geometric meaning interpretation of a root. Geometrically, a root of equation fx is equal to 0 is the value of x at which the graph of equation y is equal to fx intersect the y-axis. Suppose we have the graph of y is equal to fx, then at x is equal to alpha, it crosses the x-axis. So then this is known as the root or 0 of equation y is equal to f of x. Now, we know that for a polynomial equation of degree n, there are exactly n roots, but it may be real roots or it may be complex roots or even it may be multiple roots. But a n degree polynomial equation will have exactly n roots. But this is not the case with transcendental equation. A transcendental equation may have one root or no root or even infinite number of roots, which depends on the form or type of the equation f of x. For example, suppose we have equation sin x minus x is equal to 0, then we know that this equation has only a single root which is x is equal to 0. But if we have equation tan x minus x is equal to 0, then we know that it has an infinite number of roots. Now, we will discuss the method of finding the roots. There are two types of method available to find the roots of algebraic and transcendental equation which is of the form fx is equal to 0. First is the direct method. Direct method gives the exact value of the roots in a finite number of steps. Means it gives us exact root. and there are no round of error. An important property of direct method is that it determines all the roots at the same time. Second method of finding root is indirect method or iterative method or numerical method. Indirect method or numerical method gives us approximate root. The general procedure to find root in numerical method is that we start with one or more initial approximation and then obtain a sequence of iteration which in general converges to actual or true solution of the root. The numerical method gives us one or two roots at a time. Now, as we know, in previous classes we have find the roots of a quadratic equation by using the Sridharacharya rule, which says that roots of an quadratic equation is given by minus b plus minus under root b square minus 4ac upon 2a. Or even we can find roots of polynomial of degree 3 or higher by using factor method. For example, we have an equation of the form x to the power 3 minus 6x square plus 11x minus 6 is equal to 0. We can factor it into x minus 1, x minus 2 and x minus 3. So the roots of this equation is 1, 2 or 3. Also, we can factor x to the power 4 minus 16 into x square minus 4 and x square plus 4. So roots of this equation is plus 2 and minus 2. In this way, we have find the roots in previous classes. But here we will discuss that problem in which we can't find the roots by the method we have previously studied. Because for a large number of problems, it is not possible to find exact value of the roots of the function. So, what we do? For solving higher degree algebraic equation or transcendental equation, we use numerical method. By using numerical method, we get approximate root. Now, what is approximate root? Approximate root means we will find that value of x which approximately satisfies the given equation. Approximately means if we put that value of x in the f of x, it is approximately equal to 0. So, this is approximate root. So, in general, by using numerical method, we get approximate root. Now, the numerical method is further divided into two categories. First is bracketing method and second is open method. Now we will see what are they. First is bracketing method. In bracketing method, we require two values and we bracket the root in between them. Then we systematically reduce the width of the bracket and track the error for convergence. The example of bracketing method is bisection method. The second method is open method. We can start the open method with a single value. It is systematic trial and error scheme. Open method is computationally more efficient, but there is a one drawback that it may not converge. And the example of open method is Newton-Raphson. In the next lecture, we will discuss this method in detail. Now, in this lecture, we will see how the bracketing method works. Now, this is a graph from MIT Open Course which shows the general ways in which root may occur on a bounded interval. Means we have taken a graph of a function f of x in a bounded interval. Now, if the function is positive at both the boundary, as in the figure 1 and 3, function is positive at both the boundary, then the function either may have no root or have even number of root. Now, we are taking the cases where the function has opposite sign at the boundary. Then there are odd number of roots in the interval. But there are some exceptions of this in general rule, which says that suppose we are taking the function with opposite sign in the boundary, then the function may have even number of root if the function is tangent to the x-axis or the function is discontinuous function. These are the general way in which root may occur on a bounded interval. So in bracketing method, what we do? We bracket the interval in which root may lies. Now, we will discuss the intermediate value theorem. Sometimes it is also known as fundamental theorem for finding the roots of equation fx is equal to 0. Now, we will see what it says. Suppose we have a real valued function, means f is a function from real number to near number and it is a continuous function. Now, if we choose two real number a and b such that f of a into f of b is less than 0, then fx has at least one 0 root lies in between a and b, as we have seen in the last figure. If this interval is small enough, it is likely to contain a single root. In other words, if a continuous function has different sign at 2 points, it has to go through 0 somewhere in between. Means an interval AB must contain a 0 root of a continuous function f if the product f of a or f of a into f of b is less than 0. Geometrically, this means that is f of a into f of b is less than 0, then the curve f has to cross the x-axis at some point in between a and b. Now we can see it graphically. Here we have taken the case where f of a is negative and f of b is positive. Then graph have to cross somewhere the x-axis, and this is the point which is the root of the equation f of x. Now here we have taken f of a negative and f of b positive, but there are one more possible case. F of a may be positive and f of b may be negative. So actually what we should have, f of a into f of b should less than 0. Means we have opposite sign at the boundary. Then we can bound or found the interval in which the root lies. Now we will see the general observation to try the roots. Suppose we have been given an equation and the sign of the coefficient of equation are with opposite sign. Like in this example, coefficient of first term is positive, second term is negative, and third term is also negative. Means the sign of the coefficient of the equation are with opposite sign. Then in these cases we try positive roots. But suppose if the given equation coefficient are with the same sign, means all the coefficient are positive or all the coefficient are negative, then in that case in general we try negative roots. How? Let's see. Suppose we have to solve this equation x to the power 3 minus 2x square minus 4 is equal to 0. So we assume f of x is equal to x to the power 3 minus 2x square minus 4 is equal to 0. Now to find the root, we put x is equal to 0 in the equation. Then we will have f of 0 is equal to 0 to the power 3 minus 2 into 0 square minus 4 is equal to minus 4. It is a negative number. Next we will take x is equal to 1. Then f of 1 is equal to minus 5. It is again negative. Now we will take x is equal to 2. Then f of 2 is equal to minus 4, which is again negative. Then we will take x is equal to 3. Then f of 3 is equal to 3 to the power 3 minus 2 into 3 square minus 4 is equal to 5, which is positive. So we have f of 2 is negative and f of 3 is positive. So our root lies in between 2 and 3 from the intermediate value theorem that we have seen. So what we do, we try to find the root in between 2 and 3, which lies in between 2 and 3. Here we have taken integers, but in practice we can take any real number. Now let's see one more example. Suppose we have to find the roots or solution, solve the equation x square minus 4 sin x is equal to 0. Here the first term is positive and second term is negative. So what we do, we try positive root. We assume fx is equal to x square minus 4 of sin x. Now in this unit in general we take x as a radian. So by taking x is equal to 0, we have f of 0 is equal to 0 square minus 4 sin 0 is equal to 0. Now take x is equal to 1. Then f of 1 is equal to 1 square minus 4 into sin 1 in radian. Then we have minus 2.36, which is negative value. Now we put x is equal to 2. Then f of 2 is 0.36 is. So this is positive. F of 1 is negative and f of 2 is positive. So our root lies in between 1 and 2. Let's see one more example. Here coefficient of all the term are positive, means all the coefficient are with same sign. Then here in general we try negative roots. Now how? Let's see. So let's assume f of x is equal to x square plus 4 sin x. Now put x is equal to 0, we get f of 0 is equal to 0. Now put x is equal to minus 1, then we get f of minus 1 is equal to minus 2.36, which is negative. Then put next x is equal to minus 2, then we get f of minus 2 is equal to 0.36, which is positive. So our root lies between minus 1 and minus 2. In this way, in general, we bracket the roots and try to find the roots of given equation. That's all for today's lecture. In the next lecture, we will discuss bisection method in detail. Thank you.